Hello viewers, in this video we will discuss on the concept or the terms equation of state and state variables. Normally, equilibrium condition of a thermodynamic system is expressed by variables called as state variables. Okay, so equilibrium state of thermodynamic system is expressed by variables called as state variables. Normally for a gas, for expressing a gas, we have variables such as we know pressure, volume, temperature, mass. These are the state variables for a gas. Okay, so normal in many conditions we see that the many thermodynamic systems are not under equilibrium. For example, expansion, a free expansion of a gas. We see that the pressure is not uniform throughout. But after some time, at last we see that the pressure reaches the mechanical and thermal equilibrium at the end. Okay, so what I am going to say that the thermodynamic equilibrium of a system depends only on the state variables. Okay, so what is the expression with respect to the state variables? What is the equation of a state? Okay, so now what is the equation with respect to the state variables? Equation of state, here it is given by PV is equal to mu RT. So PV is equal to mu. This is the equation of state for an ideal gas. So pressure, volume, amount of substance with respect to moles, universal gas constant and temperature. Okay, so we have equation for real gas also. For your knowledge, I am writing the equation for real gas also. The equation is which is equal to RT. Okay, so this is the equation for a real gas. Okay, so this is given by, this equation was given by van der Waals. This is the van der Waals equation. Van der Waals equation for a real gas. Okay, this is the equation of state which is represented by the state variables. These state variables are divided into two. See that the state variables it is divided into two. Okay, so one is extensive variable and another one is intensive variable. Okay, what is this extensive variable, intensive variable? Extensive variables, they depend on the size. Of the system. So extensive, they depend on the size of the system or the amount of matter in the system. What in case of intensive? They do not depend on the size of the system. Okay, so which variables we call it as extensive, which variables we call it as intensive? Okay, so I write some of the variables. So extensive and intensive. So in case of extensive, see that we have volume, we have internal energy and mass. So these are the some of external variables, extensive variables. In case of intensive variables, we have temperature, pressure, density. So these are intensive. These variables which do not depend on the size of the system, these variables which depend on the size of the system. Okay, now see that when this temperature could be marked here, this point, this point, this point. At each point I can easily say the value of temperature. Let us take in case of volume, you cannot express volume like what I've expressed in case of a temperature. So volume could be expressed with respect to the size of the matter. For example, see, so volume could be expressed with respect to the size. Okay, so volume comes under the extensive properties. Okay, so these are the variables which comes under extensive intensive properties, and this is about the overall equation of state and state variables. Okay, thank you.